Next order of business is to meet with Mr. Tazeski and Mr. Howard regarding the water treatment plant upgrade that we've been talking about.
Good evening.
We almost lulled you to sleep there, didn't we? I saw you nodding off there.
That planning, it's a tough one.
Some people
Trying to
find
be where we are.
some people find it exciting.
Very exciting.
Thank you, Mr. Chairman. Thank you, board members.
Yeah, exactly. Some people try to find other facilities.
Some people
We all
find
have our little niches.
some people find water treatment a snoozer.
Yeah.
Can't be any more exciting
Nobody
than
we
that.
know, though.
Nobody
Certainly
on the
not.
side of the table.
Well, thank you, Mr. Chairman. Thank you, board members, for allowing us to be before you. Just before we get started, I'd just like to at least just mention again with the dry weather pattern, and we did put a code red out yesterday. I'd just like, again, to advise all our residents out there that there are water restrictions in place, and we do need the public's cooperation fully to make sure that we don't have to go any further for restrictions. I would say we're about 4.5 inches down in precipitation where we should be. We're classified as a moderate drought, certainly in western and central Mass, in southern New Hampshire right now. And they're predicting a warmer than normal July and August, so we have to be, proactive rather than reactive on that there. And one of the things, obviously, is outdoor, what we consider non-essential watering. Automatic sprinklers, washing cars, washing the buildings, sidewalks, so on and so forth there. So with we get some regular rainfall and the public's cooperation, we should be okay. But if those two things don't happen, we could be in some more difficulty, so to speak, there. But at least I'd like to advise the board and the public that that is the situation, and always we need the public's help in cooperation in these matters up on that.
What kind of volumes are we doing?
Well, we're up around 5 million up there, which is, we're up there getting maxed out there. Our average day should be around 3.6, 3.7, so, and it's mainly in the high and reduced high, which is the center town, southern sections that we're seeing 1 million gallons extra in there, and most of that is outdoor water usage, if not fully out there, When you start having 2, 3, 4, 5 days and start going the second week, you have more and more people deciding, geez, I got to do something. I want to save my lawn, I want to do this, I want to do that, and it all accumulates and it all seems to come together over there. But we're not alone. Certainly most towns here in Central Mass, Worcester's at a stage 1, certainly. Over there, because they depend more on snowfall than we do for the reservoir system. There's no snowfall, so they started out the year in a deficit. It's been very dry since there. I think, if I read it correctly, since 1966 is the lowest level for Worcester in their reservoir, so it goes back quite a long ways there. So it'd be good just to advise the public again. We need the cooperation, and we thank you for their cooperation. To matter at hand, Paul Howard, Tater and Howard's here. We did meet with the board, early in the spring to go over the manganese filtration plant, the design, the concept, and the costs there. We had applied to state revolving fund for 2% funding previously there. We're due for October 15th, Paul, I think, for design completion, approval by December 31st, the end of this year, and bidding out early next year. Since we met with the board, Paul and myself have gone over, I guess, many reiterations of the plans and details, and maybe Paul can go into some detail, how we got there. So we've come up to what we feel is a firm, pretty much a firm price that encompasses all the matters at hand down there at the plant. I'll let Paul get a little more into detail on that.
Okay, the first was the proposed schedule, which is very similar to the schedule that was presented in February. It's only shifted a month because of the cost of the new plant being in excess of $10 million. It requires some pre-qualification of contractors, so we've added an extra month for that pre-qualification of contractors. So basically, it's the schedule that Bob had just gone over with a complete construction in October of 2018. It's about an 18-month construction.
And this will still be done under Chapter 30, Section 39M. 39M, that's how we're doing this.
149, Chapter 149,
okay.
because it's you have to have subcontractors. So 3039M is underground construction utility. This is above grade.
So we're not going to consider this horizontal construction?
No, No, typically pump stations and treatment facilities. If they're an ancillary part, if we had a $5 million pipeline project going and a $500,000 pump station along with that, that could be bid under Chapter 39. But we need 149 for vertical construction, so we'll have subcontractors in the trades that exceed the subcontractor value. Typically roofing, masonry, HVAC, plumbing, painting. On the next page is changes to the project since our last meeting. They've been quite significant. When we were going over the project, the sewer number 4 was the only source in town that was not going to be treated at the facility. Right now, it bypasses the facility, and Bob adds extra chemical into the plant effluent so that when it mixes with sewer number 4, they get the required pH and contact time that he wants. And we just saw that it didn't make sense. The manganese concentrations have been increasing in sewer 4, and since it's already piped to the facility, it would be very easy to incorporate it into the facility. So we expanded the facility from 6 million gallons a day to 7 million gallons a day. And we had done that prior to, we had met with DEP, and we got approval of our pilot test proposal in early April. And we had met with DEP and decided this before that and went over that with DEP, and they concur with that decision to put Sewell through, and then said that we should expand the plant to the 7 MGD. Part of that approval letter also, DEP wanted us to design the facility now for log removal of viruses. It's not a requirement. It's only a requirement if you have a bacteria problem in the system and it's traced back to the source, but it didn't make sense to add this to the facility at a later date. It would be at a much higher cost to do that. So to incorporate it in the facility now, that if anything ever happens, since this is really the only source of supply in the entire system is going to be going through this facility, that facility be prepared to address a situation if it came up in the future. So we've added that clear well, and as you can see, the footprint of the plant has expanded quite substantially. And under this whole section of the building now is that baffled clear well that will give us that 4 log removal. Basically, as you look at this plan, water is pumped into the pressure filters that we discussed at our last meeting. Previously, we have existing those 2 pack tower aerators, and we were going to utilize those aerators for pre-treatment. But what happened when we got further into the design, the IDI, who was here with us last time, that manufactures the filters, thought that the pack tower aerators were adding too much dissolved oxygen into the system, whereby we were going to have to bypass some of the strippers to blend the water, and it just didn't make sense that we're trying to treat that water for VOC removal, that we would bypass part of it, and it would make the Bob's operation of the facility much, much harder to do. So, in all of their existing plants, they inject dissolved oxygen right into the header pipe. So that's what we're doing. It's very easy to control the process that way. So what we looked at was doing that and then still incorporating the pack tower aerators, where we'd have to pipe it back out through the aerators, then pipe it back into the clear well. And we looked at the cost of incorporating and upgrading what we had to do to the existing facility and to the aerators, that it was actually $500,000 more expensive for us to incorporate those existing pack tower aerators into this design. So we went with 4 deep bubble aerators, so that water will flow through the filters into the deep bubble aerators, which will perform the same function that the pack tower aerators do today. So it'll raise the pH and drive off any volatile organics. The water then is discharged into this baffled clear well, and then pumped with vertical turbine pumps sitting over that clear well that will pump that water directly into the system, and then it will be injected with the chemicals that are required, chlorine, fluoride, and KOH if we needed to have a finished water pH, but we feel the pre-chemical that we're using, along with the debug aerator, that there won't be a need to add KOH to the effluent of the water. But we'll have the ability to do it, but it probably won't be required.
And not adding the phosphate will then help us on the wastewater side.
Right.
When it gets to
We're putting
Westbrook.
the ability to have phosphate in the system, as you know, because of everything that's happened lately with, in Flint, Michigan, with the corrosion control and the furor that has caused throughout the United States. People, state officials have lost their job, EPA officials have lost their job, local people are getting prosecuted. That, you know, the corrosion control is a very serious issue. So we feel, and a lot of our clients meet the lead and copper rule without adding a phosphate. The reason you could not do that previously is because of the iron and manganese in the water. So the pH you would have to raise the water would oxidize, the iron and manganese would fall out. And so it would actually, for you to meet lead and copper with pH adjustment only, would give you discolored water throughout your system. So the way around that was to adjust the pH to a lower pH and then add a phosphate to the system, which would coat the piping, and that gives you the corrosion control. But if we remove the iron and manganese so that it can't participate, we'll already participate, take it out of the system with our new treatment facility, then it allows us to put a higher pH into the system. But we would pilot that to make sure that that works and that we can meet the lead and copper, so that the facility will be designed with a phosphate, but with the intention that that phosphate would be eliminated over time as we show that we can meet lead and copper without it. So as I explained, we did now have consolidated it into one facility so that the laboratory and the control room and the laboratories that were in the existing building now will be replicated into the new building. So that building has grown in size from, it was approximately about 3,800 square feet before, and it's about 8,400 square feet now. And part of this will be, once this, it's going to make the transition to go from where we are today to this new facility much easier, because it's going to be a standalone facility. We can get it up running, process water through it as we're running in parallel with the existing facility, and then once we know we're up, tested, got all our approvals from DEP, we can just flip one switch and turn the other switch on, and we're ready to, we'll have a seamless transition of transitioning from our existing facilities to the new facility. So that's basically it. And then we have also, we submitted, I think it was last week or the week before,
Last
we submitted the Green Initiatives grant application, where we'll be looking at incorporating green initiatives into the facility. So we'll be doing a study for that green initiatives. Then the next phase is to, that if we, what we recommend to implement in that would file another grant application that would try to get funding for those green initiatives through that grant program as we construct the treatment facility.
Yeah, and I think we feel that it's critical, especially in this day and age, 2016, that we have some type of renewable energy component into this plant. I think it makes sense for the community, short-term and long-term there. So looking at a bunch of things, we're going to do this assessment, as Paul just referred to. I mean, one is to try to get heat out of the clear well, out of our water, with some heat pump systems to do that. Whatever solar component, we can certainly get into there. Whatever we have else for energy efficiency
With high
in the
efficiency
plant.
motors.
Yeah, so we're going to do whatever we can that, you know, as long as it's cost-effective and makes sense, you know, engineering-wise, that be incorporated in the building. We're also, for chemicals, for safety-wise, we're going to get away from gaseous chlorine and go to sodium hypochlorite there, which is in solution there, a granular into solution, and sodium fluoride also, though. Even though they do add some sodium to the water, it's not really a significant amount, but it's much safer handling and treating and working with inside the plant there. So we're looking at some changes over there. I mean, I consider this as certainly a well-needed, if not a critical component to the water system there. I certainly don't have to tell the board or anyone in the public about dirty water complaints or manganese in the water. It's frustrating for us, as it is for the general public. This will be one major component to try to address that. The second part, which we hope to start this fall, weather and water permitting, is to start doing unidirectional flushing throughout the system, working this fall, next spring, and all the way to the fall of 2018, when we get this thing up and running there, to really get sediment, get stuff out, so we'd be ready when this plant comes to really get, cleaner water in our tank and through the piping out there for the general public there. It's critical. There's no ifs, ands, or buts about it. We have to get this online.
Because you're still looking at a 100-year-old distribution system, and you put in a new $14 million facility, and people, when it comes online, people expect the water to be pure right away, but you're still putting it in the same pipeline, so that any event that would normally cause discolored water, fire, water main break, any
Maintenance work,
major use of water causes a problem, and then it's very difficult for Bob to control that problem. You get out and start flushing, but if you flush randomly, it just moves the water around the different portions of the system, where the unidirectional program starts at your tanks and at your facilities and moves out, so you always have clean water behind you, and it allows you to get that accumulated iron and manganese and tuberculation that's in the mains out of the mains, so that when you do put the new facility on the line, you've got a much cleaner distribution system that you're putting it to, and you're no longer adding that iron and manganese to the system, so that it becomes easier and easier for Bob to do that. It's typically done twice a year, in the fall and the spring, and he'll see that the first few times he does it, it's going to take him a lot of time, because that hasn't been done. But as you do it more and more, that the time frame gets shorter and shorter for that.
Mr. Chairman, can I ask you a question? Unidirectional. Bob, can you give us an example of pick a tank in town and how you might do that?
Yeah, unidirectional for us means that you're going to start at the source of the water, which is the treatment plant, and you're going to work to the extremities of the system, the far ends. So we break the system into maybe, say, 15 different quadrants, and by valving off, we isolate quadrant by quadrant in town. We start at one end, and we finish up at that one where it's gated off, so the water does not go beyond that. So we're going to notify the public in that quadrant, work on that, starting by the lake, basically, and working our way over to the Westboro and Northboro lines, quadrant by quadrant. We're going to have to do that. Some are going to be a lot more difficult than others, because, even though we've done flushing in town, we haven't done this comprehensive. There's a lot of sediment, certainly in the pipes, and tubercles, from the cast iron itself in there, plus the manganese and, other accumulations through the years. It's going to take some time. But I want to try to get the town set up so when the plant gets on, it won't be that much of a transition to get that. And that's what our customers want, and that's what they expect, and that's what they should have out in the system.
How long will that effort take?
It's a couple years. We got to do spring, fall, this year into 2017, then 2017 into 18, and then I think if everything goes right, we're about October 2018 for the startup of the plant, so that would be the fall flushing right then.
Yeah, it'll probably take about 2 months per flushing period
Yes.
for you to get through the entire town. It's
Yeah.
very labor intensive in the fact that because you're doing it unidirectionally, you have to shut down a lot of valves to always keep the water coming from behind you. So the secondary benefit of that is that you're really doing a hydrant and valve maintenance program as you're doing it. So we'll find that part of the scope for this is to revisit the plan after it's done the first time, because you'll find valves that are inoperable, you'll find mains that you thought were connected are not connected, or mains that you didn't think were connected are in fact connected. So you identify all those things, and then we make adjustments to that flushing plan, so the next time you go out, you incorporate all the things you find in the field into the subsequent plans.
Bob, if we do the flushing,
Yes.
like flushing a hydrant, right?
Yes.
So were you going to do it on that scale? Do you meter it so we can account for it, or does it make a difference? Is that still considered unaccounted for
Oh,
water
you know
either
me
way?
and unaccounted for water, Mo.
What?
You know me and unaccounted for water. No, but in all seriousness, yeah. We figure out what the gallons permitted is coming out, what the pressure and the flow is, and we're going to keep a record of how long we flush each hydrant. So we'll have that, in our annual report for unaccounted for water. It's gonna be significant, it's gonna be a high number, no.
And the plan is
about
actually
that.
done through a hydraulic model that predicts exactly what the flow is and the duration that you need to flush that area. So each individual, he'll have a sheet for each individual hydrant that's flushed that will give a predicted flow. Bob will check that flow in the field, and a duration. They'll time that duration, so he'll know approximately what it's going to take to flush that, but he'll keep those actual records, and then he'll account for that water in his annual water supply statistical report.
Yeah.
Mr. Chairman?
Thank you.
Just one final question, Bob. Do you anticipate much practical impact on residents with dirty water and the like when you're in this
Well,
big flush?
there's going to be some, obviously we're going to do some during the day. Some we might have to do at night, but even notifying people, there's no way we can say we have no effect on businesses or public. We're going to try to minimize it the best we can, give people as much warning, that we don't do laundry, don't do water-related activities, but invariably something happens at some point in time over there, and different things happen over there. We're trying to minimize it the best we can. Won't be 100%. I hope I get as close to it as I can, though.
But if you're successful, you will be moving a lot of
Oh, yeah,
material,
we'll be
right?
moving a lot of material, and that's the good news for a lot of people, but there's going to be, some people that are going to be inconvenienced, certainly, as we do this.
The short-term impact is minimal for the long-term benefit.
Yeah. Thank you.
Sure, thank you.
Anyone else have any questions?
Can I ask one follow-up?
Yep.
On your estimated price, you have a contingency of 1.2 million.
Yes.
Where do you see, from your experience in the current marketplace, where the likely areas of concern are within this project? Or are you in a position to say?
For as far as dipping into that contingency money? SRF, the program, wants you to carry a 10% contingency going in.
Yes.
And then after it's constructed, they drop that to 5%.
Okay.
So.
But from what you're
but
seeing,
Typically, it's unforeseen conditions, but pretty much we know what's happening on that site, so we really find, if you look at the average for Tater and Howard's construction projects, especially vertical construction, we average less than 1% change orders on our projects historically throughout our 24-year history. So that doesn't count owner requested change orders that are,
No,
in
that's
the middle
different.
of
I
the
realize
job.
that.
Right, but unforeseen change orders that would be dipping in a contingency, it's typically less than 1%.
The building itself is a fairly simple building.
yeah, that's,
And a lot of the value of the contract is in the equipment that's going inside the structure itself.
Very,
So
very
it's-
expensive equipment.
So that equipment, all those prices should be well known to us when we put the bid, together.
and if there was something out there in the marketplace that was fluid, that gave you some level of concern.
Well, it always, you never know the timing of when you bid something, construction for public work, so that it's if there's a lot of work on the street at the time this project happens to go out, then the bids tend to be higher. But if it's the opposite way, then you get the benefit of that. And there's no way of us knowing that, of predicting, 6 months from now, what's going to be on the street at that time.
All right, but we're bidding at the correct time.
Always better to bid in the
February,
winter
March,
for
right.
spring construction, because it gives a contractor the knowledge that he's going to have that project to go ahead with in the spring.
Thank you very much.
And I would say to your point too, Jim, there's always some differences in commodity costs, whether it's steel or, these other commodities. It could, depending on world and global events, things could go up or down too, but right now, it seems to be a fairly good number there.
I didn't know if
And
there
it's
was
Buy
something
American
that
because
you were
of
thinking of.
because of
that might-
SRF.
Right.
So it's Buy American on all the steel, so.
Right. Thank you.
Okay.
No problem.
Anything else?
No, I think that's it. This is the number we're going to be looking at.
Right, and that's,
Right now.
and that'll be September 26th,
Special town meeting.
special
at
town meeting,
26th.
September 26th, to get this authorized.
And what do we get from the state on this, if anything, with regard to some sort of reimbursement?
Right, this will be a 2% note. We'll probably be borrowing the money through the SRF program, and it'll be 2% money.
So, no, we pay for this.
Right, but the grant is 2% money.
Right. Cheap money, but
Right, you pay for it, but it's
14.5 million
2%.
of us.
Right.
Yeah, there's no, there's no 1970s 75%
Just
federal.
asking.
and 15%
It wasn't like in
state.
Westboro, we did get some stimulus money in
Right.
Westboro.
Okay.
Thank you.
Thank you.
Good
Thank
job.
you very much.
Good to see you, Bob.
Yep, thank you very much.